Let's ask this question, what is pi? Some will say, well, pi equal to 3.14, but they will say approximately. Well, others might say it's equal to 22/7. That's again approximately. So what exactly is the definition of pi? Well, it is the circumference of circle divided by diameter of circle. Okay, let's take a circle that is of radius r. And let's try to measure the circumference of the circle. But if I want to measure this circumference with a scale, then I cannot do it. It is a curved circumference of a circle is the measure of length of a curved region. Let me draw some straight lines. Let this be the center of circle. Let this be x-axis. Let this be y-axis, and let this distance be h unit, and this also be h unit. And we have circle to be of radius r unit. So this is also r. That is the radius of circle. And let's draw another line. We want to approximate the circle with a line, with a number of lines rather. Alright, so we have drawn two lines that are at a distance h unit from origin. And also at a distance h unit from the circumference from this point. Now, what can we say about this length? Will it approximate will this line approximate this arc? Maybe. Let's see. Okay, so what we want is we want to approximate the circumference using these lines. How many of them are there? There are 8 of them. Now we observe that this measures same as this, and this measures same as this, and also this. So these 4 are of same measure. So let's try to determine the length of this line, and then we multiply by 4. First we observe that circumference is bigger than, let this be of length S1, let this be of length S2. Circumference is bigger than 4 times S1 plus S2. Now let's determine length of S2 first. this point is having coordinate, let's say 0 comma, we observe that x coordinate to be 0, y1, y0. This point is having coordinate h comma y1. This point is having coordinate 2h comma y2. Now by Pythagoras theorem, if it is y1, then y1 square by Pythagoras theorem we need to apply Pythagoras theorem again and again. So let's do it once. Y1 square plus h square equal to r square. So that imply y1 square equal to r square minus h square. And so you got y1 equal to root over r square minus h square. So what can we say about S2 then? Well, we observe that this length, if we draw a line parallel to x-axis, then this length will be y1. So S2 will be equal to y0 minus y1. y0 is of radius of circle. So your S2 equal to rather S2 square. Again, by Pythagoras theorem, S2 square equal to y0 minus y1 whole square plus h square. This implies S2 must be equal to root over, let's write h square first, h square plus y0 minus y1 r minus, we have just computed y1 equal to root over r square minus h square whole thing square, y0 minus y1 whole thing square. Y1 turn out to be r square minus h square. What about S1? S1 again, S1 square, that's the hypotenuse square, equal to y1 square plus h square. Y1 square is r square minus h square plus h square. So we have replaced y1 square by r square minus h square, and it turns out that S1 equal to r. Okay, so what can we say about circumference then? Therefore, circumference is greater than, we have already observed circumference is greater than 4s1 plus s2. Where was it? Yes, here we have observed circumference is greater than 4s1 plus s2, 4 times s1 plus s2, and that is equal to 4 times s1 turns out to be just equal to radius of circle, and s2 is the big number. Let's write s2 only here. S2 is equal to this number, so this is equal to 4 times R plus, let's take R common from S2. R into, from square root, if you take out R, you'll have H by R whole square plus 1 minus root over 1 minus H by R whole square, whole thing square. Now H is half of R, so this is just equal to 4 times 4. Even okay, we can take out R, and 4R 1 plus root over 1 by 2 square plus 1 minus root over 1 minus 1 by 4 whole thing square, and that is equal to 4R 1 plus square root of 1 by 4 plus 1 minus root 3 by 2 whole thing square. That we can compute. Let's use calculator. Now this implies pi. What is pi? Equal to circumference divided by 2r. Diameter is twice the radius, and that is greater than, because circumference is greater than this number, 2 into 1 plus square root of 1 by 4 plus 1 plus 3 by 4 minus 2 root 3 by 2. We can simplify it more, and that is equal to 1 plus root over 2 minus root 3, and that is equal to 2 times root 3 is approximately 1.7, 2 minus 1.73, so you will get 0.6, 1.6, somewhere roughly 3 point something. So we observe that pi is greater than 3. Can we do something more than that? Answer is yes. Can we have a better estimate for pi? Answer is absolutely yes. But how? For that purpose, instead of dividing this circle into just two equal, this radius into 2 equal half, let's divide it into more number of equal parts. So we have a bigger circle now, and the radius is broken into a large number of smaller units. And what can we say about the circumference now? Observe that last time this length of this arc is much bigger than this line, a little bit bigger than this line segment. However, if we draw this kind of figure whereby we are dividing radius into large number of different edge, then we observe that the length of line segment is much closer to the length of arc. Length of my line segment is much closer to length of arc. Length of line segment is much closer to length of arc. So let's determine the y1 in this case. Again, y1 equal to root over r square minus h square, y2 equal to root over r square minus 2h whole thing square, y3 equal to root over r square minus 3h whole thing square, and so on. Okay, we know yn. Let this be S1. So let this small straight line be of length S1. So S1 equal to root over h square plus y0 minus y1 whole thing square. Then similarly S2, this length be S2, the length of slanted line be S2. So S2 equal to root over h square plus y1 minus y2 whole square, and S3 equal to root over h square plus y2 minus y3 whole square. And we can go this way and we can compute it. If we do computation this way, then we'll get better and better value of pi. We'll be able to approximate pi more accurately. Let's do it for